Hello everyone, I am Dr. Janavi Chakrabarti, Assistant Professor, Department of Mathematics, Bardhaman College of Engineering. Today in this video, I am going to discuss how to find the numerical solution of first order ordinary differential equation using Runge Kutta method. Basically, we will consider the fourth order Runge Kutta method. Now let us see what is Runge Kutta method of fourth order. Consider first order ODE dy by dx equal to f of xy with initial condition y at x naught equal to y naught. Now to find y1, that is y x1, we will first calculate k1, which is given by h f of x naught y naught, k2 h into f of x naught plus h by 2 y naught plus k1 by 2. We will find k3 h f of x naught plus h by 2 y naught plus k2 by 2, and k4 is given by h into f of x naught plus h y naught plus k3. We will first calculate all these values k1, k2, k3 and k4. Then y1 is equal to y naught plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. So this is how we will find the y1. Similarly, we can get y2, y3 and so on. Similarly, y2 is given as y1 plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4, where k1 is equal to h into f of x1 y1, k2 is equal to h into f of x1 plus h by 2 y1 plus k1 by 2, k3 is equal to h into f of x1 plus h by 2 and y1 plus k2 by 2, and last one k4, we will get it as h into f of x1 plus h y1 plus k3. So in general form we can write it as, in general form, yn plus 1 equal to yn plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4, where k1 is equal to h into f of xn comma yn, k2 is equal to h into f of xn plus h by 2 yn plus k1 by 2, k3 will be equal to h into f of xn plus h by 2 and yn plus k2 by 2, yn plus k2 by 2, and k4 will be h into f of xn plus h yn plus k3. Also here this n will be equal to 0, 1, 2, 3 and so on. So this is the general form for Runge Kutta method of fourth order. Now let us find numerical solution of first order ordinary differential equation using Runge Kutta method of fourth order. Now look at the first problem where we need to apply Runge Kutta method of fourth order to find an approximate value of y, and the equation is given as dy by dx is equal to x plus y, and initial condition is y at x equal to 0 is 1. Given dy by dx is equal to x plus y with the initial condition y at x equal to 0 is 1. Here f of xy is equal to x plus y, that we know. Dy by dx equal to f of x comma y. So f of x comma y we can consider it as x plus y, and x naught is 0, y naught is 1. Let us choose h as 0.2. Choose. Therefore x1 equal to x naught plus h, which is given by 0 plus 0.2, 0.2. Now if we find y value at x1, that is 0.2, we get the answer. Okay. Therefore, by Runge Kutta method of fourth order, we have y at x1 is equal to y naught plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. Let us take it as equation number 1, where k1 is equal to h into f of x0 comma y0, which is equal to h is 0.2, f of x0 is 0, y0 is 1, which is equal to 0.2 into, since f of x comma y equal to x plus y, so we get here 0 plus 1, 0.2 into 1, 0.2. Now we will next find the k2. K2 is given as h into f of x0 plus h by 2 comma y0 plus k1 by 2. H is given as 0.2, f of x0 is 0 plus h is 0.2 by 2 and y0 is 1 plus k1 is 0.2 by 2. We get 0.2 into f of 0.1 and this will be 1 plus 0.1. Therefore, we get 0.2 into f of 0.1 and 1.1. 0.2 into this will be x plus y. So, 0.1 plus 1.1. We will get 0.24. Next, we will find k3. k3 is given as h into f of x0 plus h by 2, y0 plus k2 by 2, which is equal to h is 0.2 into f of x0 is 0 plus 0.2 by 2, y0 is 1 plus 0.24 by 2. We get 0.2 into f of 0.1, 1 plus 0.12. So we have 0.2 into 0.1 plus 1.12. We get 0.244. Now we need to find k4. k4 will be given by h into f of x0 plus h, y0 plus k3. h is 0.2 into f of x0 is 0 plus 0.2, y0 is 1 plus k3 0.244. 0.2 into f of 0.2 comma 1.244. So we have 0.2 into 0.2 plus 1.244. So if you compute this, you will get 0.2888. Now we got the values for k1, k2, k3 and k4. Now we will substitute this k1, k2, k3 and k4 in equation number 1. Substituting y0, k1, k2, k3, k4 in equation 1. We get y at 0.2 is equal to y0. y0 is 1 plus 1 by 6 k1. k1 value is 0.2 plus 2k2. 2 into k2 is 0.24 plus 2 into k3. k3 is 0.244 plus k4, which is 0.2888. If you calculate this in calculator, you will get 1.2428. It was asked to find y value at x equal to 0.2. So we get y at 0.2 as 1.2428. Now look at this problem, where we have to solve dy by dx equal to x minus y with the initial condition y at 1 equal to 0.4. We need to find y at x equal to 1.1 using Runge Kutta method of fourth order. Given dy by dx equal to x minus y with the initial condition y at 1 equal to 0.4. Here f of x comma y equal to x minus y. x0 is 1, y0 is 0.4. Let h is equal to 0.1. Therefore, x1 is equal to x0 plus h, 1 plus 0.1 equal to 1.1. In the question, it was asked that we need to find y value at x equal to 1.1. Now we will use the Runge Kutta method of fourth order. Therefore, by Runge Kutta method of fourth order, we have y at x1 equal to y0 plus 1 by 6, k1 plus 2k2 plus 2k3 plus k4, where K1 is equal to h into f of x naught y naught. Now let us find what will be K1. H is 0.1, f of x naught is 1 and y naught is 0.4. So 0.1 into f of xy is given as x minus y. Here we can write 1 minus 0.4, which is 0.1 into 0.6, 0.06. So K1 is 0.06. Now let us find K2. K2 is equal to h into f of x naught plus h by 2, y naught plus K1 by 2. H is 0.1, f of x naught is 1 plus h is 0.1 by 2, y naught is 0.4 plus 0.06 by 2, which is equal to 0.1 into f of 1.05, comma, this will be 0.43, which is equal to 0.1 into, this is f of xy means x minus y, 1.05 minus 0.43. So this will give you 0.0620. Now we will find K3. K3 is equal to h into f of x naught plus h by 2, y naught plus K2 by 2, which is equal to h is 0.1, f of x naught is 1 plus 0.1 by 2, y naught is 0.4 plus 0.0620 by 2. We will get 0.1 into f of 1.05, comma, 0.431, which is equal to 0.1 into 1.05 minus 0.431. If we compute this value, we will get 0.0619. Now let us compute K4. K4 is given by h into f of x naught plus h y naught plus K3, which is equal to 0.1 into f of x naught is 1 plus 0.1, y naught is 0.4 plus 0.0619, which is equal to 0.1 into f of 1.1, 0.4619. This is equal to 0.1 into 1.1 minus 0.4619. If we compute this, we will get 0.0638. Now let us substitute K1, K2, K3, K4 in equation number 1. From equation 1 we have y at x1 equal to y naught plus 1 by 6, K1 plus 2K2 plus 2K3 plus K4. Now substituting the values, we get, substituting x1, y0, k1, k2, k3, k4, we get y at 1.1 equal to y0 is 0.4 plus 1 by 6, k1 is 0.06 plus 2 into k2 is 0.0620 plus 2 into K3 0.0619 plus K4 is 0.0638, which is equal to 0.4619, which is the required answer. So this is how we use Runge Kutta method of fourth order to find the numerical solution of first order ordinary differential equations. Thank you.